Can you pick up your head? Go ahead and stand back here for 4 minutes. I'll bring you back. Yeah, 4 minutes. Bring your nose back there. You're going to move right along. No, because your head's down. Fall asleep. You're looking tired. She'll be going back too. 4 minutes. Come on. Carlos, will you read the word for me?
Firefighters are trained on a ladder. The ladder is a 34-degree angle with the ground and it is 20 feet long. To the nearest foot, how far is the base of the ladder?
Alright. Who remembers what cube stands for? What's the C? Shout it out. Circle the numbers. Circle the numbers. Go ahead and do that. Let's circle the numbers on our word problem. Do you see any numbers, Isaac? We should just circle. 34. I saw you circle something else too. 20. Alright, so circle 34 and 20, because those are our numbers. What about U? What does the U stand for?
Underline math words.
What math words do you see, T?
Angle, feet,
Okay.
foot,
Okay.
base.
Anybody else see any other math words? Nearest, okay. What about B? What's B stand for?
Font. What you need to find. Box. What you need to find.
Box what you need to find. So we need to box what we need to find. If your head's too heavy, I'm going to stand. How do you stand? In the back. Ellen? I'm going to ask you to stand in the back of the end performance. Yes. And I already told you. Right, bring your notes. Box what you need to find. Who already boxed their word problem? Anybody? T, what'd you box?
How far is the base of the ladder from the building?
How far is the base of the ladder from the building? And then what's our last one? What's E stand for? Nobody remembers what E stands for.
Evaluate and draw diagram.
Alright, so your diagram is already drawn for you, right? I drew it right up here on the board. Our next problem here, we have our diagram, we have our cubed word problem, we know what we need to find, we need to apply that math knowledge to this random picture, right? We know we're working with right triangles, we know we're working with their sides and angles, and their relationship to each other, right? So we're going to be making a right triangle somewhere out of this picture. Does anybody see one? I see one. Here's our one leg, right? Here's our bottom leg. And here's our hypotenuse, which is our longest side. How far is the base of the ladder from the building? That's what we need to solve, right? That's our unknown. Corbin, head up. That's our x, right? This is the base of the ladder down here. This is our building, right? So how far is this distance? That is unknown. What else do we know? We know it makes a 34-degree angle.
Against the ground, so
Angle with the ground. So if we look back to our chart on the first page, is that going to be this angle, or that angle?
that angle.
Right, so this one's our 90 degree, it can't be that one. It's an angle from the ground. So if it's coming from the ground, our angle is going to be right here. Our unknown angle.
No, it's known.
It's known. What's it known?
34 degrees.
Oh, it tells us it's 34 degrees.
Right there.
Alright, so this is 34 degrees. We know one other thing. We're told that the ladder is 20 feet long. Yep, okay, so we put that here. Right? The ladder's 20 feet long. Is that right? Is it?
No.
Exactly. So this isn't our ladder. This is our building. Here's our ladder. Our ladder is 20 feet long. That's wrong. Alright, so now we have all our numbers on our picture. opposite, adjacent, and hypotenuse. Our opposite is right here. We don't know that, right? Can't use it. Adjacent, adjacent here, right next to it, is x. So opposite is, we don't know it. It's question mark. Not really useful to us. Adjacent is x.
Over.
Hypotenuse is 20. And our angle is 34 degrees. All of your notes, you guys should have this work copied down onto your notes as well so that you can look back and reference it, right? So if we know adjacent and we know hypotenuse, we have a relationship that we can circle back to, right? If we put adjacent over hypotenuse, that equals the cosine, right, the C, of our angle 34.
That's the answer.
Is that the answer? That doesn't look like an answer, that looks like a problem. That looks like an equation. Do you guys know how to put cosine, sine, and tangent into your calculators, or do you want to review that?
You know how to do it.
Okay. So, we still need to find this x. The question's asking us what's this distance, right? So to find that x, we have to do inverse operations. So we multiply by 20, multiply by 20. These cross out. X equals cosine of 34 times 20. Can someone who has a calculator plug that in for me?
Cosine of 34
Times 20.
16.4.
16.4 feet. So how far is the base of the ladder from the building?
16.4.
16.4 feet. Excellent. All right, Keenan, you can have a seat. Once you're done writing that.
16.5 feet.
Is it 16.5?
No.
Oh, okay. It's 16.58. Did you guys get that?
Yeah.
I mean, either one, I mean.
Well, no, it's important. 16.58. If we're rounding to the nearest one decimal, it would be what? If we're rounding to one decimal, it would be 16.6. What if we were rounding to the nearest whole number?
17.
17. All right. Next problem down there, the group practice. I want you guys to work in your tables, chat with each other. You need to cube it. You need to draw a diagram. And then you need to find the missing value, right? So talk with your tables. Try and get something down for that, and then we'll go over it all together, okay? Looks like you guys know how to cube. Do you know how to draw?
Can I go sit down?
Yes, you can. Do you know how to cube? Hmm? Yeah, it's always going to be, you're always going to be drawing a right triangle. But you want to draw it so that it makes sense to your word problem, right? So jump on this dog. Shadow. So this, where would you draw this central?
It's on the ground.
If you had to draw a stick figure of a person standing. Right. So where would his shadow be? Or like on your triangle, where would it be? That would be the shadow, right? So if the sun's coming from here, cast a shadow.
It would be on this side.
So Mr. Mitchell, shadow,
Figure out how far.
and then you have an angle of elevation.
So, like 6'4".
Where would you put an angle of elevation? No, that's right.
So, 5'1"
You're elevating, right? Angle of elevation. So you know. Or three point.
Oh, if you ever,
Well, you could, but you already drew a right triangle there, and you're going to be doing so too, right?
I wrote
So you know 58. You know its shadow is 4 feet long.
So what we have,
And what is it asking you to find?
we have the sun. Where's the sun?
Exactly. So that's what your x. Now,
Where's the sun?
huh?
You know,
No, he's asking how tall is
sun?
Mr.
How we draw the sun?
Mitchell?
That's part of the problem. There's the sun. Okay, now what's the sun doing? Now, it says the way the sun shines was an angle, right? Okay, so we're gonna draw like this. So the sun shining on an angle, it's usually a diagonal line. So if you go down to the sun, it's diagonal. Alright.
You're going to be setting up your
Of this angle.
ratios like so.
Alright, so that means
So
the
like this is
sunlight
your
is
angle.
coming
So we can,
here to here.
yeah.
Right, this angle that is creating measures
And then where's the 4 feet?
3, so you can draw the round now.
the point.
You're gonna label that angle. Now you know what
Exactly.
the angle is.
I'll be right there.
Now, apparently, this
You're
is
close.
not.
So now you guys are the same spot. Right here.
So apparently, it's 3.39.
What? Sine, cosine, or tangent?
So,
This is your angle.
in order for you to have this image of shadow, you gotta have.
X,
this
your opposite
So,
adjacent, or
what is the
dependent.
problem?
Okay. And 4
He's
is,
standing
okay.
there. The
And
sun
then that's
keeps
your
saying, here's
angle.
gonna see the shadow.
So what can you write that looks like the thing on the work on the board?
You should be there.
Angle of elevation.
That'll be, and what's the question?
So if you're elevating something,
No, it's
So,
your tangent, this angle is going to be here.
opposite over here.
The sun.
We're looking for X.
alright, so you have that place, you got a place there,
Right.
right angle with the sun.
So I was wrong.
So the question is,
Then
that's
how are you
what's
going to set up? Okay, what's the ratio like that?
so you gotta ask yourself.
Using sine, cosine, and
I'm
tangent.
trying to find a leg of the triangle, right?
Well, why don't we label what you know? So if you know that x is opposite, why don't you write that? Opposite equals x, just like we put up
This
there.
line, find this one.
Then 4, what's 4?
You know, sine and cosine, what do both sine and
Okay.
cosine need?
So sine, cosine, and tangent is opposite and adjacent.
Well, sine
So
is opposite of
tangent
cosine.
of what?
Right, cosine is adjacent, but they both need what? Okay, in this situation
Right.
here.
Just the angle.
Right, so the other thing. Remember, right? So,
Now solve for your x, right?
in this situation, if you use A, you have to put
Yes.
4.
Then
No,
where
we don't, right? Now look at the increase rate.
What do you do?
We're not finding like that there. What do we have?
So,
We have 58 degrees.
With-
We have, so we don't have that partner. We have one of them. It's gonna be adjacent. Not yet. We can, I have the adjacent. So we have the adjacent right now.
Flip the bend. Okay, are you talking about this at the end? Doing our 15 minutes at the end? Looks like you're.
And
Did you guys all get how tall Mr. Mitchell is? How tall is he?
he's gonna be,
Is that accurate?
right?
Because it was tagged.
You're saying.
I did.
of what?
angle of elevation.
Oh, I got it right now.
Did you guys answer for how tall? 6 foot? 4?
That was easy.
kind of done everything.
Can I move some water? Obviously.
You guys have the answer for how Thomas can control?
We don't know the opposite.
What do you
right?
guys
Some water.
Nice.
We don't know the opposite right now, right? That's just a mental fact, like, we know the equation. So,
Are you understanding
I
it?
would
Trying to
I
find
would this right here.
Oh, it is right here.
You don't want to write anything down to help you out, or do independent practice, or you can't ask anybody, you can't work together with
So
anybody?
we don't know the opposite, right? So we'll let it
Every day.
He played it since on summer break. He was lost now. Now he was.
You get the grown man room.
So they.
Alright, you guys, wrap up your last thought with your table. We're going to go over it real quick. If you've already moved on to your independent practice, I'm going to ask you to stop, pause real quick, take a look up here. Alright. Can someone raise their hand for me and read the word problem that we're working on as a group here? Anybody?